So we were studying about state of matter or states of matter. This video is part 2. So see the next point. So next point is telling that most of the observable property of chemical system with which we are familiar is bulk properties of matter. The properties associated with collection of large number of atoms, molecules and ions. So atoms, ion and molecule. So ion means it may be cation and anion. So plus is called cation and minus is called anion, right? Atoms. So it contains electron, proton and neutron. And molecules, how it is formed? When two atoms combine each other. Oxygen having last electron is 6. Right? We know the atomic number of oxygen is 8. 2,6 electronic distribution, right? So it needs 2 more electrons to complete its octet. So I have given it 2 electrons. In the similar manner, another atom of oxygen, it is having 6 electrons. So it will share the electron with this atom. So it is forming, it is completing its octet. This is called octet rule, right? So this also containing 8 electrons by sharing. And these free electrons is called lone pair. These free electrons is called lone pair. So when two atoms combine each other, it forms a molecule. So this is the molecule of oxygen. That is O2. Understood? Now, an individual molecules of liquid doesn't boil. Right? So it is talking about now boiling point. So boiling point. Suppose I am taking a single molecule of water, right? So it doesn't boil because only one molecule is there. So it doesn't boil. So it requires bulk quantity, right? So it doesn't boil. Collection of water molecules have wetting properties, right? So, and for the boiling, we required bulk. So right here, so for boiling the liquid or water, boiling the liquid, we required large amount of quantity. We required large amount of quantity. Right. So now see the next point. So collection of water molecules have wetting properties. When we take large amount of water, that liquid have wetting property. So collection of water is wetting property. So it has wetting property. Third point, see, individual molecule do not wet. So if we take single molecule of water, so it doesn't wet the substance. Single or one molecule of water does not wet the substance, right? So now see the next. Water can exist as solid, ice, that is solid, can exist as liquid, and it can exist in the gaseous state as vapor form or a state. So these are the 3 states of water. So I will write here 3 states of water. 3 states of water. So first, that is solid. So exist in the form of ice. Second is liquid. We write as H2O or water we say. So third one is gas. That is called water vapor. water vapor, or it is called a steam, right? So physical properties of ice, water and steam are different. So you can see here, so these all three having three different physical state. These all three of it has different physical property, different physical properties. So you can see here, so ice exists in the solid form, this water is exist in the form of liquid, and this water vapor exists in the form of gas. So these are the different physical states of the water, right? Now see the next. So all the three states of water, chemical composition of water remain the same. Characteristic of three states of water depend on the energy of molecule and on the manner in which water molecules aggregate. Same is true for the other substance also. So in all the three states, solid, liquid and gas, their chemical composition is same. Chemical composition is same, right? Their states are different only. States of water is different, right? Now see the next. Chemical properties of substance do not change with the change of state, but the rate of chemical reaction depends on the physical state. So see, so rate of reaction depend on the physical state. Rate of chemical reaction depend on physical state. I will explain it. So see how it is depending. So rate of chemical reaction. Suppose there is gas. So we take hydrogen gas and oxygen gas to form the water molecules, H2O liquid, right? So you can see here, I have taken liquid because liquid reacts fast as compared to solid liquid. So rate of reaction, who will do fast? Gas is more reactive, least reactive is solid, and gas lies between these two. So this is the order of rate of reaction. This is order of chemical rate of reaction. Chemical reaction, right? So it depends on the physical state also. So gas state reacts fast. So right here, gas, a state of any element or substance, gas state of any element or substance do react fast as compared to solid and liquid. So write it down. So we are studying states of matter. So why we are studying? As I have told in the previous slide that rate of reaction depends on the state of it. So when it is in the gaseous form, it reacts fast. So to understand that, so you have to understand the nature of intermolecular forces. Nature of intermolecular forces. Intermolecular forces. Right. Next is molecular interaction. How molecule is interacting with the another molecule. Interaction. Molecular interaction. Next is effect of thermal energy. Thermal energy of particles. Because thermal energy decides the states of substance. Thermal energy balance between these determines the state of substance. So if thermal energy is high, right, so that will contain the solid. So this point is very important. So thermal energy, when atoms are tightly bonded, then its thermal energy is more or highest. When in the gaseous form, its thermal energy is less. Thermal energy is less, right? So for that, so see, first we will study about intermolecular forces in a explanation manner. So next our topic is intermolecular force. So first one is intermolecular force are the force of attraction and repulsion. So these force can be attractive or repulsive, right? Between interacting the molecules. So where it is exists between the atoms and molecules. It may be atoms or it may be molecule. These terms doesn't includes the electrostatic force that exists between the two positive charges. So it is not equal to, does not equal to attractive force. Attractive force means plus and minus. So this force is also called an electrostatic force, right? So this force exists between the positive charge and negative charge. So this intermolecular force, so it is not equal to this one, right? So there is no positive and negative charge between the atoms and molecules. So it is neutral atoms and molecules. Neutral atoms and molecules. Understood? So force that holds the atoms or molecules together, that is called covalent bond. So when suppose I am taking oxygen atom and this oxygen atom, right, they are sharing the electrons. So these two atoms of oxygen is held by covalent bond. So this bond is called covalent bond. So when it forms, when it shares the electron, so share of electron is called covalent bond. Covalent bond. So right up to this point first. So now see the next point. Next point is attractive intermolecular force are known as van der Waals forces. So when there is attraction between atoms and molecule, that is called van der Waals forces. Van der Waals forces. So remember the name of this scientist. We will study more about it. That is called, it has given the equation of real gas. Real gas equation. So see here. So van der Waals forces gives the attractive intermolecular force. Attractive intermolecular forces. Right. So this is the Dutch scientist which have given, name is given in honor of him. Right. Now see who explained the deviation of real gas from the ideal gas. Right. So there are two types of gas we will study later in this chapter. Ideal gas and real gas. So ideal gas are those gas which obey the laws like Boyle's law, Charles' law, Avogadro law, like that. Avogadro laws. So we'll study different types of law and how these real gas are different from that ideal gas. right? So see here, van der Waals forces vary constantly in magnitude and include dispersion forces. So its magnitude changes. Whose? Van der Waals forces. So magnitude is different. Magnitude is different for different molecule. Is different and includes the dispersion force. Includes dispersion force. This force is also called as London force. London force. Understood? And another, it is also called as dipole-dipole interaction. Dipole-dipole forces. And dipole-induced dipole forces. Next name is dipole-induced dipole forces. Induced dipole forces. Right. See the next point. So a particular strong type of dipole-dipole interaction is called hydrogen bond. So when hydrogen of atom, it combined with another atom of hydrogen, that is called hydrogen bond. Hydrogen bond. Or another way of telling hydrogen bonding is hydrogen bonding is, see here. So suppose I am drawing the diagram of ammonia in which one lone pair is there and there is water molecules. So I will draw like this. So it is having electron and this nitrogen having 5 electrons in the last orbit. And by sharing it has completed its octet. So what will happen? This oxygen having 6 electrons in the last orbit and it is having 5. So in this molecule, this will attract the electron nitrogen towards itself. So it will form delta minus and this will form delta plus. In the similar manner, this part will become delta minus and this will be delta plus. So there is a force of attraction between these two, plus minus, delta minus and delta plus. So that is called hydrogen bonding. Understood? So it may be between the two different molecules or between the same molecules also. That is called hydrogen bonding. Now see the next point. Only a very few elements can participate in hydrogen bond formation. There it is treated as separate category. Right? So only limited amount of molecules or compounds do hydrogen bonding. Right? So they are kept in the different category. At this point, it is important to note that attractive force between ion and dipole are known as ion dipole forces. These are not van der Waals force. Right? So when there is attraction between ion and dipole, so it is called ion dipole force. Ion dipole force. It is not equal to van der Waals force. Van der Waals forces. Understood? So let's see the different forces separately in explanation. So first is dispersion force or London force. Dispersion force or London force. I will explain it. So we are studying dispersion force or it is also called as London force. So see the points first. So atoms and non-polar molecules are electrically symmetrical and have no dipole moment. Right? So it is talking about atom. So atom has no charge, right? Single atom has no charge. Right? Or non-polar molecules means, suppose non-polar means, non-polar molecules means it doesn't have any charge. Does not have any charge. that is called non-polar, right? So you can take example of CH4. There is no charge between carbon and hydrogen. So this is non-polar, right? If you are talking about polar molecules, so it has positive and negative charge like water. So it will be plus and OH minus. Like HCl, it has plus and minus. So it is called polar. So when anybody asks from you that what is polar molecules, so it has charge, have charge between them, between atoms and molecules. Non-polar means it doesn't have any charge between them. Understood? And have no dipole because their electronic charge cloud is symmetrically distributed. And atoms and non-polar doesn't have any dipole, has no dipole moment, because electrons are distributed symmetrically, because electrons are distributed symmetrically. Understood? But a dipole may develop momentary even if such atoms and molecules can be understood as follows. We have two atoms A and B in the close vicinity of each other. It may have so happen that momentary electronic charge distribute in any atom because unsymmetrical charge cloud is more on the other side. So it can be slightly developed. How? I will explain it. Suppose this is the first atom, that is called A, and this is atom, that is B. Right? So this is symmetrical distribution of electron charge distribution. So this is your symmetrical distribution of electronic charge cloud. Right? So suppose there is transfer of any electron from here to here, then it will become minus and it will become plus for a moment. So that time it can become a polar molecules, right? So this is called temporary dipole of atom A and B, right? So this force of attraction was proposed by German scientist called London. So for this region, force of attraction between two temporary dipole is called London force. So when it is developed temporarily, that is called London force. So this is temporarily dipole induced force. Temporary, right? So right up to this point.